Hi there, folks. Today we're looking at triangle congruence by SSS and SAS, and that stands for side, 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 and side, angle, side. When we look at congruent polygons, that's when all the different pieces match up so we can say the polygons are congruent. But with triangles, we don't necessarily need all of those things. Okay? See, there's a special relationship in a triangle between the side and the angle opposite that side. And so if all the angles, if all the sides are the same, then all the angles are automatically the same, that kind of stuff, okay? Or really proportional when you go the other way. But the point here is that you don't necessarily need all of the pieces to show that the two triangles are congruent. One of the ways that we can do this is by side, side, side. So if all the sides match up, that's all you need. You don't need to show anything in terms of the angles. They will automatically be matched up. And it's because if we kind of lock three congruent or correspondingly congruent sides together, the angles are automatically going to be locked into a very specific dimension, which means that all the angles are going to be congruent automatically. Okay? And so really for triangles, the first thing we have here is that, hey, if all the sides match up, then the triangle is congruent, and I don't need to show anything else. Okay? And that's what the side, side, side postulate is saying. So if three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent. I don't need anything else. I can just say that the triangles are congruent based on the sides. Okay, I don't need to say anything about the angles. For example, if I look at something like this, let's use that postulate to do a proof here. Given that AD is congruent to BC, and that's already marked on the picture, AB is congruent to DC, also marked on the picture, I want to prove that triangle ADB is congruent to triangle CBD. All right, so we use this to prove triangles are congruent. And so once again, I'm going to do my statements and my reasons here. And like always, I'm going to start with what I know. And that's given. And so when I look at this thing, if I compare those two triangles, I already have that two of the sides are congruent. I just need to show that one more side is congruent, and then I'll have side, side, side. I'll have all three sides, and then I can say the triangles are the same. And so when we look at this picture, the other side of triangle ADB is side BD. And the other side that I'm missing right now of triangle CBD is side BD. And so really, we're talking about the same side, which means this thing is congruent to itself. And I can always say that something's congruent to itself because that's my reflexive property. So I'm going to say that BD is congruent to itself, BD. And that's the reflexive property. And now from here, I basically have three sides from one triangle are congruent to three sides from another triangle. So I can say that the two triangles are congruent. Okay? So triangle ADB is congruent to triangle CBD. And it's as simple as saying this for the justification. You can just put SSS for side, side, side. Okay? We'll all understand what that means. And, again, this is kind of a whole series of different ways that we can prove the triangles are congruent. You don't need as much information as other polygons. That's what's special about these. You only need three pieces of information here, and those three pieces are the three sides. Okay? If I take a look at something like this guy, it says find the measure of angle E given these two triangles. And notice it doesn't say that the two triangles are congruent, but notice all three sides of one triangle match up with all three sides of the other triangle. So I can say that they're congruent. And it's important to maybe list the congruency statement just to make sure everything's listed correctly. So in this one, I might say triangle ABC. And then think about how you have to label this based on, like right now, AB is right here. That's this guy. Well, that has to match up to EF in the other triangle, okay? And then the next side listed BC. See right here I had AB and then followed by BC. Well, that's the one with one dash. So over here, that's got to be this guy, okay? So you just got to make sure we're matching it up in the same way. And so for this one, I'm going to say triangle. Well, the first one went A, B, B, C, okay? So this one has to go E, F, F, D. So E, F, D. And notice the last side that matches up, ED, is congruent to AC. So the labeling here, once again, becomes very important to make sure that the right pieces match up. Okay, and now that those are matched up, we can kind of see which angles match up. Angle A goes with angle E. Angle B goes with angle F. Angle C goes with angle D. And so in this particular example, I could find the missing angle here. So this guy right here. Remember, the three angles inside a triangle add up to 180 degrees. And so if I show this work, maybe I'll take it off to the side and do it. So I've got 95 plus 25 plus the measure of angle A equals 180. And again, most of you can probably do this in your head, and that's okay. All right, so that's 120. And then we subtract that 120 from each side. Okay, and it's okay to do that one in your head. I understand if you want to do it that way. Okay, but just to show you that work for those of you who might be feeling a little bit lost to this point. Okay, and so now as I kind of match this thing up, I have to go back to that kind of naming protocol and say, okay, well, angle E is the thing I'm looking for. That's matched up with angle A. So guess what? Angle E is also 60 degrees. Okay. It's that simple. And if it asked me for the measure of angle D, well, I can match that up with C, so that's 25 degrees. If it had asked for the measure of angle B, well, that matches up with, the measure of angle F, which matches B, so that's 95 degrees, okay? So it's important to understand, all right, side, which sides match up, so I understand which pieces are congruent. That helps me with the angles as well, okay? The next one we're going to look at here is the side angle side postulate, okay? And once again, along the same lines, the idea here, and this is really important, that the way it's listed is side angle side, okay? It's not side angle, all right? Or for the forbidden angle side. We're never going to use that one, okay? This is side angle side, which means it's two congruent sides with the angle in between those sides. And the order there is very important. Okay, so when we talk about side angle side, it's got to be two sides with the angle that's kind of in between those two sides. So the angle that's created using those two sides. All right, that's what has to match up. All right, so the order here is very important. And so the idea, once again, is if I have two things that are locked in terms of the length, and the angle in between is locked in, well, you see that third side is going to have to be a certain length. Okay, it's going to have to match up. And so, like, again, if I had a side that's this long and a side that's this long, and this angle was locked in place right here, well, then this side is automatically this length. And these angles are kind of locked in at being whatever they happen to be. And so if I duplicated, those two sides, and I duplicated the same angle, you see that it kind of locks us into having the same length here again, okay, with the same angles here again. All right. And so that's the idea behind this postulate, is if I have two sides that are locked and the angle in between is locked, well, the third side has to automatically be locked. Okay. And so it makes these two triangles congruent by side angle side. All right. So once again, just to restate this thing, if two sides and the included angle, the angle in between those two sides of one triangle congruent to two sides, and the included angle, the angle in between of another triangle, then the triangles are congruent. Okay? So let's use this. If I was given something like this guy, so given C is the midpoint of AE, and it's also the midpoint of BD. All right? So that's what's given here, is that point is the midpoint of those two sections. So once again, statements and reasons. Here we go. So I start with what I know. And what I know is that C is the midpoint. I'm going to abbreviate of AE and BD. Okay? And that's given. So now let's think about what that means. And students will tend to jump the gun here, and they'll go right to saying things are congruent. Well, they're only congruent because of what was given. So now that I've stated that's the midpoint, now let's think about what's congruent if that's the midpoint. So if like C is the midpoint of A, what was listed first, AE, well then these two sides are congruent, okay? Because that's what happens with the midpoint. It breaks it into two congruent pieces. Likewise, if C is the midpoint of BD, it means that these two segments are congruent, because that's what that means, all right? When we talk about this thing being the midpoint, it means that it breaks the thing into two congruent pieces. And so now that's the next thing I can state. I can say, hey, I know all this stuff about these pieces being congruent because that's what the midpoint gives me. So now I can say that BD is congruent to CD. Likewise, I can say that AC is congruent to CE. And that's because that's what happens with the midpoint. So I'm just going to say that's the definition of the midpoint. Okay? And now from here, so I have two sides. Think about what we just talked about. We want two sides and the angle in between. So the angle in between is that angle that's kind of there at C. It's ACB and DCE. And so we have to think about, all right, are those congruent? Do we know if they're congruent? And if so, how are they congruent? And if you want to, I'm fine with this. You'll have to check with your teacher. Instead of labeling this as ACB, I'm just going to put a little 1 here and a little 2 here. So instead of having to call it angle ACB and angle DCE, I'm going to call it angle 1 and angle 2. Now, if you can't add extra labels here, then you have to leave it as angle ACB, all right? But use some of those things to your advantage. So I'm going to say angle 1 is congruent to angle 2. And I've decided that they are congruent, but the question is, how are they congruent? Think about what kind of angles those are. Well, those are vertical angles. So vertical angles are congruent. And again, if we don't have the ability to draw that 1 in there or that 2 in there, you can easily just leave this and say, oh, angle ACB is congruent to angle, ooh, that is an ugly looking congruent sign. Let me try again. To angle DCE. Okay? And I only mention that because like on a test or something like that, you might not be able to write in those angles. So you might have to state it as angle ACB and angle DCE. All right? But keep in mind, that's why we have extra naming protocols, so we can make life easy for ourselves. Okay? And so as I look at this thing, I have two sides of one triangle and the included angle, and two sides of the other triangle and the included angle, all being shown to be congruent. So now I can say that the triangles are congruent. Okay? Step 4, triangle ACB is congruent to triangle ECD. And I know that because side angle side. Okay? I just showed that the two sides with the angle in between are congruent to two sides with the angle in between. So now I know the triangles are congruent. Okay? If I look at these guys, so I've got a bunch of pairs of angles, and these are all separate examples here. Okay, so I've got 4 separate examples. I want to determine which triangles are congruent, so determine if the pair of triangles are congruent, and then determine how I know they're congruent. Okay, so like in something like this guy, I've got two sides congruent to each other, and the angle in between are congruent. So yes, I can say that these are congruent. So I can say that these two are congruent, and I can say that because of side, angle, side, because it was the two sides and the angles in between. Okay. If I look at the next one, I've got two sides that are congruent, and then on one triangle, it's the angle in between. On the other triangle, it's not the angle in between. See, like if this guy was here instead, if it was showing us that angle, if we moved that, well, then I'd have the angle in between on each. But one of the triangles isn't showing us the angle in between. Okay, so we can't make a determination here because it's the wrong angle being displayed. Side angle side only works if it's two sides with the angle in between for each triangle. Okay, so this one I cannot say that these are congruent, so I'm going to say not congruent for now. Okay, if I look at the next one, I see 3 sides of one triangle congruent to 3 sides of the other triangle. There's one side that matches up with each. And again, the order doesn't really matter because I could turn each of those triangles to make them display in kind of the same direction. But I have one side that matches up, another side, and a third side. So I can say that these are congruent. And that's because of side, side, side. See, with side, 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 the order doesn't matter because we can rotate and change the triangle a little bit. But with the angle, it matters when we're doing side, angle, side because it has to be the angle in between. Okay? And then if I look at this one, the first thing I should notice is that there's there's three sides that match up, the one side, the second side, and the third side. So I could say that these are congruent because of side, 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 for sure. But then as I look, maybe I want to say side, angle, side as well. Let's check. Notice the side that has 2 dashes and the 3 dashes with the angle in between. So here's 2 dashes, 3 dashes. Do I have the angle in between? Well, the answer is no. So I can't say that these are congruent because of side, angle, side. I can only say that they're congruent because of side, side, side. Okay? Later, when we talk about matching up the corresponding pieces and now saying that they're congruent because the triangles are congruent, I'd be able to get the side, angle, side eventually out of this. But as it's stated, I only have side, side, side here. I don't have side, angle, side. Okay? I'm missing the angle in between. That's not the one that I have. Okay? And then if I look at this last one, this is a very similar example to one that we already did. But the idea here is now I can shorten up this proof a little bit because I have these 2 new postulates. Instead of having to show all of the pieces the same, I only need a select number of pieces now. So here we go, statements and reasons. And the other advantage here is I don't need as much in terms of the given if I don't need as much to prove that the 2 things are congruent. All right. So this one, I'm going to start with what I know, like always. Angle cab is congruent to angle CAD. And segment AB is congruent to segment AD. And again, that's given. And of course, the first thing I like to do once I have that down is I want to label this on the picture. All right. I like to see it over here. So CAB is this one. And that's congruent to CAD, which is this one. And then also AB is congruent to AD. And so what I have here, if we think about the 2 that I've looked at so far, the side, 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 and the side, angle, side, well, really, it's really going to be really tough to show all 3 sides are congruent at this point because I only have one side and one angle at this point. So having the angle should tip me off in terms of going towards the direction of something like side, angle, side. And so when we think about this, if I want the 2 sides and the angle in between, I have one of the sides. The other side that would kind of sandwich that angle for like triangle ABC would be this side right here, AC. Okay? And the other side that would sandwich this angle for triangle ADC would also be AC. Okay? See, this is the angle in between these 2 sides. Okay? And likewise, in that top triangle, this is the angle in between these 2 sides. And so what I really need to do is show that AC is from triangle ABC is congruent to AC from triangle ADC. Well, that's the same side. So once again, we're at that point where we can use that reflexive property. We can say that AC is congruent to itself. Again, that's my reflexive property. And by doing so, I now have the 2 sides with the angle in between. I have side, angle, side. So triangle ABC is congruent to triangle ADC, and that's because of side, angle, side. Okay? But the idea here is I needed a lot less stuff this time to show that these 2 triangles are congruent. I didn't need as much in terms of the given, and I don't need to do as much in terms of the proof. Okay? Because of these 2 postulates, and again, this is unique, this is special to triangles, I don't need as much stuff to show that they're congruent. Okay? I can do it by just showing the sides are congruent, or showing 2 sides with the angle in between. Okay?